Next to the graphical part, sound is also a key component of immersive and compelling real-time applications. It gives users audible characteristics of surroundings and immediate feedback on their actions, which can be crucial, especially in virtual reality. In this tutorial, we will show the ways to fill a virtual scene with sounds and apply special effects to them, and review the most common use cases. To hear sounds in UNIGINE Editor, make sure that the audio toggle on the toolbar is enabled. In UNIGINE, any camera in the scene acts as an audio listener, so you need to have a camera to hear sounds. Objects that produce sounds are called audio sources, and they are represented by two entities, ambient source and sound source. Ambient sources provide a flat background sound that can be used to create overall atmosphere and play music. This type of sources can't have any specific place in 3D space. That's why the ambient source is available only through API. Sound sources are like omnidirectional loudspeakers that have a certain position in space. They're suitable for emulating spatial sounds, enabling the listener to subconsciously evaluate the distance to the sound source and pinpoint its location. UNIGINE supports a virtually unlimited number of sound sources. Besides that, lifelike propagation of sound requires taking into account a lot of factors, such as geometry of space and material features. Sound reverbs represent reverberation zones, giving sound a natural and authentic sense of place. To make things work, first import audio clips you want to use in your world. UNIGINE supports regular audio formats such as WAV, MP3, and OGG Vorbis, both mono and stereo. You can preview an audio asset by selecting it in the asset browser and using the audio player in the preview panel. Holding the Shift key, right-click to open the Create menu, go to the Sound section, and choose Sound, then Source. You may need to enable the Sounds icon in the Helpers panel. Here we have a sound source. It plays the default sample sound. We can switch it on and off via the play and stop buttons in the Parameters window. We can assign an audio asset by dragging it into the sample field. By default, the audio clip is played once, but we can loop it and have it played repeatedly. Now we can place our sound source to a desired location. And we've got a working fan with a convincing sound effect. The sound source is a 3D position spatial sound. Note the accurate binaural effect when the camera is being moved around. It is provided due to support of HRTF out of the box. Keep in mind, this feature is available only for mono audio clips. Stereo sounds won't pan because they're already panned. We can choose whether the sound should play on, enabling via the corresponding parameter. By default, the sound always starts playing automatically when the world is loaded or the sound source node is created and enabled. But you can disable this option when necessary and control playback explicitly. The next Restart on Enable parameter is easier to understand with a more extended audio clip. For example, music. You can type a sample's name to search through all the assets currently available in your project. Nice music. Let's play the source next to the radio to create a feeling that the music is coming out of it. We can use this option to define if the clip should play from the beginning each time the sound source is enabled. Uncheck it and playback will resume each time exactly from the point it was last stopped. We can choose between loading the clip into memory entirely or streaming audio data from a certain location. Sound sources support the bit masking mechanism. Check out the bit masking video tutorial to get familiar with this system. Sound source mask specifies sound channels of the source. We can choose the channels the camera hears via the sound mask in the camera settings, without toggling multiple sound sources on and off manually. This is a very convenient workflow for fast development of dynamically changing environments. As for other settings, you can adjust pitch to change the frequency of the audio clip, and gain to change loudness of the sound source. Other important parameters are the minimum and maximum attenuation distances. The maximum distance defines the sphere covered by the sound source. Outside this sphere, the sound source is completely inaudible. The minimum distance determines the inner sphere, where the sound is loudest, full gain. Outside this area, the sound starts rolling off gradually towards the maximum distance. You can also choose attenuation model, the way the sound fades off as the camera moves away from it. Go to Windows, Settings, open the Global Sound Settings, and select the attenuation mode. 6 different functions are available: inverse square, linear, exponent attenuation, and their clamped versions. For example, now the sound is rolling off according to the inverse square law, which is the most accurate behavior. If you don't want the sound source to attenuate, just set the maximum distance to infinity to keep its gain constant at any distance. By default, the sound source emits sound in all directions. To limit the spread of sound, the inner and outer angles are used. The inner-oriented cone shows the area of full sound gain, which reduces gradually to the outer cone. The outer gain parameter lets you define whether the sound is heard outside the cone. You can also limit high frequencies of the sound via the outer gain HF to make it more convincing. High frequencies are likely to be more directive in the real world. In UNIGINE, you can simulate sound occlusion as well. If the sound source is not directly visible from the place where the listener is located, the sound will be muffled. Set up the occlusion bit mask to define the geometry that is enabled to occlude the sound source. Use the adaptation parameter to define how fast the change in gain of the sound source is. You can also adjust it globally for all sound sources in the scene. Make sure that the source occlusion feature is enabled. To occlude a certain sound source, mesh surfaces, such as this wall, should have a matching occlusion mask. The occlusion coefficient of a surface describes how much it affects sound in case of occlusion. Now, let's just move the player out of the sound perception area and the sound gets weaker, just like in real life. This is crucial for VR applications where high accuracy of sound propagation is a requirement to ensure full immersion. Occlusion is a very performance-consuming feature since it requires numerous intersections to be detected. Therefore, it is recommended to use simple geometry LODs as occluders to keep performance high. Don't forget to disable this option for each sound source that doesn't require occlusion, or disable it globally when sound occlusion is not used at all. Reverberation zones enhance plausibility of sound sources by reproducing lifelike effects of reflecting sound in different environments. Sound propagation in a long corridor differs from that in a large hall. Even physical features of materials come into play here. You can set the size of a box-shaped zone via the Edit Size mode to define the volume of the simulated environment. The zone requires its reverb mask to match the mask of the sound source to affect it. Furthermore, each camera has the reverberation mask, defining whether the zone is heard by it. Reverberation zone has a lot of parameters available for adjustment. You can also select one of the numerous environment presets. Thus, we can easily switch between indoors and outdoors by selecting a stone-clad corridor, mountains, forest, underwater, and much more. Reverberation zone parameters are formed by 3 components: early reflections, late reverberation, and echo. All these parameters can be easily changed. We can choose the overall gain for all the effects and decide what extent low and high frequencies are pronounced. Room roll-off is the factor that defines the distance-dependent attenuation of reflected sound. This parameter is concurrent with the same parameter of the sound source, as well as air absorption, defining the transition of high frequencies of reflected sound through the specific medium, such as fumes or dry heated air. You can choose between a more humid and a less absorbent atmosphere. Density is accountable for late reverberations. You can lower it to give more coloration to individual resonances. Diffusion determines the increase in the density of reverberations. The lower the diffusion is, the more distinct and granular the reverberation will be. The echo time and depth parameters define modulation of cyclic echo for distant sound sources. You can specify how prominent the echo will be and the time period for echo to repeat itself. Modulation time and depth stand for the pitch modulation that has no real-life counterpart. However, this effect can be used to carry the emotional load and add emphasis to the environment. Time defines the speed of periodic changes in pitch, while depth controls the amount of these changes. Control the sense of space via decay time controls. Higher values typically correspond to large, massive halls, where the reverberation period for sound is pretty high. You can fine-tune the decay time for low and high frequencies via corresponding ratios for accurate acoustic simulation. Reflection gain and delay enable you to control sound reflections from obstacles. It may give some indication of the surroundings. A strong and immediate sound reflection tells that the walls are close, and the change in tonal coloration may indicate the reflective quality of the material they're made of, while absence of reflections describes a large empty space around the listener. To define the total intensity of a late reverberation, use late reverb gain. In addition to the time of sounding, the begin time of a reverberation can be set relative to the time of the initial reflection via late reverb delay. Using all described parameters, you can control the way the sound and its reflections are physically interconnected and make them constitute accurate sonic phenomenon. You can adjust outer attenuation of the reverberation zone via the threshold parameter to avoid sound snapping and enable smooth sound transition when the listener moves from the outside area into the reverberation zone. As there may be several reverberation zones, you can decide how to treat them globally. Choose Source Reverb Mode. The single mode assures that sound sources are affected only by one reverberation zone. In the multiple mode, effects of several reverberation zones are linearly smoothed and applied to the sound, if the sound and the player are within all these zones. You can also disable effects from all reverberation zones. Let's use reverberation zone to simulate sound propagation underwater. So, we add a global water object, adjust zone size, and select the underwater preset. Now we can submerge and check it out. Let's consider other global sound settings. You can use scale to control the global pitch and propagation of all sounds in the scene. Volume stands for overall gain. The Doppler coefficient defines the intensity of the Doppler effect, a perceived shift in frequency applied to sound sources moving past the player. To demonstrate the effect, let's enable sample vehicles moving past the building. We'll have to switch to the engine viewport, which is the actual gain viewport, as the Doppler effect is enabled during runtime only. The sound seems louder as it approaches the listener and fades as it moves away. We can make it more pronounced by increasing the value. The velocity parameter defines the speed of sound and can be used for fine-tuning of the Doppler effect. HRTF toggles the binaural head-related transfer function mode on and off. This mode provides imitation of surround sound for a stereo-wired headset. Let's check how this mode affects the perception of a sound source moving around the player. Checking the HRTF option provides a natural binaural sound. But once we uncheck it, the position of the sound source becomes hard to be distinguished, and acoustics are not quite normal. Always enable this mode in your VR projects for proper spatial audio simulation. The sources stack of parameters allows mastering sound channels set per each sound source. By using the sound source mask, you can control the volume of each channel and limit the number of sound sources played simultaneously in every channel. For some situations, the editor tools may be insufficient, and fine-tuning is performed via code. Let's consider an example with several objects falling atop the table. It is impossible to predict the moment when an object collides with the table to play back an audio clip of collision. This can be processed via code by using contact callbacks. All you need is to include the UNIGINE sounds and UNIGINE physics headers in your app world script. Then in the init function, find the required dynamic object, add a contact callback to their physical rigid bodies. Thus, you register a function, which will be called for an object on a collision event. In the function, you can obtain the very contact point and impulse, and place a new sound source at the exact position where the contact occurred. After that, run the application and look at the result. Every object is accompanied by a sound when colliding with the table, ground, and other object, which brings the scene to a more convincing level. After all setups and preparations of the scene, you can also add a background music by using the ambient source via code. So let's switch to the IDE and again take a look at the App World script. Include UNIGINE sounds and UNIGINE file system for it. In the init function, create an ambient source by specifying the internal path to the audio clip. Let's enable the loop for it and start the playback. In this example, we have used a simple string defining the relative path to the audio asset. You may need to use a global unique identifier of the asset in order not to lose it in case the file structure of the project or the location of the asset changes. In this case, it is recommended to engage the component system. Please refer to our online documentation for more details. Run the project, and you'll see that the ambient source starts playing on the world initialization next to the sound sources added and configured in the editor. Sound plays a crucial role in creating an illusion of physical presence, and it is very important for most real-time applications, be it a simulator or a game. You can find more information on sound objects and settings on our developers portal and in the online documentation.